So, hello, this is the review questions we're going to do for Chapter 3. I'm going to go over quite a few questions here that will be similar to the questions on your chapter test at the end of this week. So, you do need to take notes. You need to write down all the questions that I do. I'll let you know when you need to take notes and when you don't need to take notes. So, let's get started. We're going to start with Chapter 3.1. So, Chapter 3.1, they've given us a graph here with three lines drawn on it. They've called this one fx, this one can be gx, this red line, and this horizontal green line is hx. Now, for question number 1, we need to now solve for question 1, gx equals 1. So when they say solve, they mean find an x that gives that value. So we are looking, where does the graph of gx, where does it equal 1? For what value of x does gx equal 1? And we can see that here, it's here. So when x equals 4, gx equals 1. So let's write that in. X equals 4. Okay. Question 2 is asking us, where does hx equal to gx? So basically, where does the line or the graph of hx meet the graph of gx? So hx is our green line, gx is our red line, and again, they meet here when x equals 4. So my answer is, again, x equals 4. Question 3, they're asking us for what values of x is fx smaller than gx. Now, if they've asked the question is an inequality, then the answer needs to be an inequality as well. So we're looking for where does the graph of fx, the blue line, where is it smaller or where is it below gx, our red line? Okay, and it's basically from here onwards, right? But we're looking for values of x, so it's from 1 and below. So our answer therefore is x is smaller than 1. Okay. Next question is asking me, where is hx smaller than fx and fx smaller than gx? Or in other words, where is fx in between h and g? So fx is my blue line, hx is my green line, gx is my red line, and we can see that the blue line is in between these two in this part. So the value, our question is for what value of x? So x is from -2 to +1. Okay, so copy down this question. I will be checking this as your homework as part of your binder checks. From now on, your homework will be to copy down the questions that we do in the slides like this, and then in class we should be able to answer questions that are similar. Okay, I'm about to move on to the next slide. So let's move on to chapter 3.2. Okay, they've given us a lovely graph here with some data plotted onto it. This must match a table of x's and a table of y's, and they have made a scatter plot, and you can see that this is roughly linear. Okay, these aren't in a perfect straight line, but we might or should be able to fit a straight line to this data, and let's see how we do that. And here's my question. So it's asking me to find a linear model that contains the points x equals 8 and x equals 3. Write out the equation and draw it on the graph. So the first thing we need to do is actually find a point, because they've just told us that they want x equals 8 and x equals 3. But we can see that the point that corresponds to 8 is 8, so our first point will be 8, 8. Okay, and our second point, it says x equals 3. So the point that corresponds to x equals 3 would be y equals 4. 3, 4. Okay, now what we need to do is find a linear model. That just means a linear equation. We just need to find the equation of a line from 2 points. Okay, we've done that a million times, and that should be pretty easy. Here's how we do it. Okay, so my slope m equals y2 minus y1 over x2 minus x1. That will give me 4 over 5. That's my slope. Okay, so I now know that y equals 4 over 5 x plus b. Okay, I now need to find that b, so I just plug in one of the points. Let's plug in 3, 4. So I know that 4 equals 4 over 5 times 3 plus b. b equals 1.6. Sorry for my terrible handwriting. I end up with y equals y equals 0.8 x plus 1.6. Okay, 0.8 is just the same as 4 over 5. Yeah, it's just in decimal form, and then we said b is 1.6. So this is our linear model. Okay, next thing to do is just to plot it on the graph, and that should be very easy because we know that it must go through 3, 4 and 8, 8. So it must go from 3, 4, from x equals 3, y equals 4, through 8, 8. So something like that. Try to draw it as straight as possible. Okay, and you can see that obviously it doesn't go through all the dots, but it does go through some of them, or 2 of them, and it gets quite close to all the others. Okay, that's how we do this question. And for the next slide, I'm going to show you a YouTube clip of just to remind you of how to plot things like this on your calculator and how to fit a line using the calculator. Now, you need to be careful because if they've asked you a question like this, okay, to find a linear model, you need to find the 2 points, okay? If they've asked you for a line of best fits, okay, then you can use your calculator. But your calculator will not give you a line like this. Your calculator will give you a line that gets closest to all of them. It might not actually go through any of the points, okay? If they ask you again, I repeat, if they ask you to find a linear model, okay, you need to work it out, to do the maths yourself, okay, to do this process, to find the slope, then plug in the points. Okay, so copy out this question, copy out these calculations and this final answer, please. Thank you. Okay, now for this slide, I'd like you to watch this video. I hope it should work on this presentation. If not, you can just search for it on YouTube. This is just a guide to plotting scatter plots on your TI-84 calculator and finding a best fit line, because you will need to do this in the chapter test. So enjoy, watch this.
Hey guys, today I want to show you how to make a scatter plot on your graphic calculator and then find the equation of its line of best fit. The first thing we need to do is enter the x and y values for our scatter plot. To do this, press stat, then select the first option, edit, press enter. We're going to put the x values underneath where it says L1 and enter the y values underneath where it says L2.
Okay, by the way, sorry to interrupt. I recommend you be doing this with your calculator while watching this, okay?
After you're finished entering the data, go to second, y equals. We want to make sure that stat plot 1 is on. So we'll press enter. And then we want to make sure that this cursor says on. So press the arrow key, press enter, and now it's highlighted. Now we want to hit graph. Notice how not all of the dots appear on the graph. In order to see the entire scatter plot, we want to press zoom. Then scroll down to where it says 9. Zoom stat. And that will give us the best view of our scatter plot. Now that we can see our entire scatter plot, it's time to calculate the line of best fit. Hit the stat button again, and this time, press the right arrow and move the cursor over to where it says Calc. In the Calc menu, scroll down to option 4, LinReg, which is short for linear regression. You could also just press 4, and then press enter. And then press enter again. A is the slope of the line of best fit. B is the y-intercept. In this case, if we round to the nearest hundredth, the equation of the line of best fit is y equals 0.85x minus 7.53.
Okay, so if you didn't manage to see that, if you only heard his voice and didn't actually see the video, then just look this up on YouTube. Yeah, you've got the browser, the address there, and the name of the video there. He explains there quite well how to find a line of best fit, so it's part of your homework, your duty, to go into YouTube now or go into a different page and watch this now. Okay, it's only 2.5 minutes long. And that's how he explains how to find a line of best fit. Okay, if you want to practice that, then you can do it on page 140, questions 11 to 16. That's a really great way to practice making a scatter plot and a line of best fit on your calculator. So to practice for the chapter test, I think it would be a very good idea if you did those questions, at least 1 or 2. Okay? Okay, let's move on to chapter 3.3. Okay? Okay, chapter 3.3 starts off with completing the square, and it'd be a good idea if you were to please start taking notes about this for your notebooks, because I will be checking it. Okay? Okay, so completing the square is basically how to go from standard form of a parabola, which is something like x squared plus 2x plus 5, to vertex form. Okay? Once we have something in vertex form like this, we know that the vertex will be -1, 4. Okay, what we need to do, what we're going to have to do in the chapter test is get something like this and work out what the vertex is. So to do that, we will have to transfer it for something like this to this, then it will be easy to find the vertex. So I'm going to show you now how we do that. Okay? So let's say we are given an equation like this and we need to transfer it to vertex form. Now the first step is always to factor out the coefficient of the x squared. In this case it's 3. Now we factor it out only of the first 2. Okay, you need to be following me with this and you need to be writing this down as I do it. Okay, so I've factored the 3 out and I've got 3x squared plus 2x, because if I was to open up these parentheses I'd get exactly this back. Okay, now second step is to look at the coefficient of the x. Okay, first step was to look at the coefficient of the x squared. Second step, look at the coefficient of the x. Now, in order to match our square formula, we need to divide this one by 2, okay, and then square it. So 2 divided by 2 is 1, 1 squared is 1. Okay, so we write it out as follows. Watch me. Okay, so I've written out plus 1, minus 1. Of course I'm allowed to do that. I can add any number and then subtract it because it will still give me 0. If I was to factor this all out, I would still get back to something like this. Okay, now, the whole idea of completing with a square was to get something like this. Okay, this now matches our a plus b squared formula. Okay, if you don't remember it, how about I pop it up over the side here. 1 second. Okay, so here's my formula here, just to remind you. Now, we now see that this, after manipulation, this matches this formula. Okay, my a is 1, or my a is x, sorry, my b is 1. Okay, so now the next step would be, okay, so this is my next step. Okay, I've taken this, and I've turned it into x plus 1 squared minus 1. Now we're almost finished. Okay, the tricky part here is remembering that these are parentheses inside parentheses. All I need to do now is again factor out this 3. Okay, because I can't leave it like that. I need it to be in vertex form. Okay, this is almost vertex form, not exactly. Okay, so I just need to open up these parentheses. Open up the square parentheses, not the rounded ones. Okay, so I've opened up my square brackets, not my rounded parentheses, and I've got 3 times negative 1, negative 3. This plus 5 stays there. It's been on the end the whole time. Nothing's changed about it. Okay, and then minus 3 plus 5 is plus 2. So there we have our lovely vertex form. So my vertex is negative 1, positive 2. This is also another tricky thing to remember, okay? When we have something in vertex form, the vertex of that parabola, okay, will be the negative of this number, because it's the number that when I plug into x, I get 0 here. Okay, so if I plug in negative 1, this becomes 0. Okay, but as for the y, it's just we just take this number. So my vertex is negative 1, 2. So in the previous example, we saw some nice rounded numbers, but that doesn't always have to be the case. You can still do it, even if you get fractions. It's just a bit more annoying and complicated. So this is question 42 on page 152. I'm going to do it very quickly, and then you can read over it, or you can pause this video and look back over it. Okay, I'm doing exactly the same again. I'm looking at this a over 3, and I divide it by 2 and then square it. Okay, so that's the number that I add on and subtract. 16 over 9. Okay, and now this matches up. Okay, this is a perfect square formula. Might not look like it, but it is. Okay, I know that this will become x minus 4 over 3 squared. Okay. Still not finished, still need to factor out the 3 out of the square parentheses only. Okay? You don't need to be writing out this, but you do need to write out this just to follow along with me. Okay? Okay, so my final answer is 3x minus 4 over 3 squared minus 16 over 3 plus 2, which is like 6 over 3, so it should be minus 10 over 3. There we go. So we've completed the square with a fraction now. Okay, so it should be very clear to you now what the vertex of this is. Okay, the vertex is negative 4 over 3, sorry, mistake, my mistake, plus 4 over 3, because we're looking for the number that when you plug it into x gives us 0. So my vertex is therefore 4 over 3 and negative 10 over 3. Okay. Now, we've found this data. Now we're going to get some information about the graph of this function using this vertex. Okay, so first of all, we should know how to plot it. Okay, I'm going to draw up. I want you to have a go at plotting it. Okay, because we know that the parabola opens up and the vertex is 4 over 3, negative 10 over 3. Okay, have a go at plotting it. Okay, so a good way to practice this would be page 152, questions 29 to 42. I recommend you do at least 2 or 3 of them, preferably the ones at the end, so maybe questions 40, 41 and 42. They're quite difficult, and if you can complete the square on them and then check your answers in the back of the book, you should be ready for the chapter test for those questions. Okay, let's move on. So here is my graph of 3x squared minus 8x plus 2. Okay, we know in the past from previous years that this parabola must open up. Okay, so this vertex, which we found in the last slide to be 4 over 3, negative 10 over 3, this vertex is the minimum. Okay, so a question they might ask in the chapter test is, where is this function decreasing? Okay, decreasing means going down. Okay, so for a parabola, it will always be, the change will always be at the minimum or the maximum. So we're looking for where the function is decreasing, or where is it sloping down. And you can see that it's sloping down anywhere from here all the way down to here. Yeah, at this point where x equals 4 over 3, the function then starts increasing or going up. So the answer to this, where is the function decreasing, would be for all x's that are smaller than 4 over 3. Okay, it should be quite easy to see that from the graph. Yeah, the function is going down anywhere, any x that is smaller than 4 over 3. Okay, in the next question, we're going to be given a graph like this, and we're going to have to work out the equation of the function. Okay, let's have a look at a question like that. Okay, write this down. Okay, they've given us a drawing of a function, and they've told us that the vertex is, let's have a look, what is it? It's 1.5, 3.5. Okay, and that it also goes through the point, the y-intercept is 0 and negative 1. Okay, and what it wants us to do is work out the equation of this formula, of this graph. So, our first step, we know what the vertex is. Okay, so we should be able to quite easily make a guess at writing this out in vertex form. So, here's our first guess. Okay, we don't know if it's correct yet. What we need to do is plug in 0, -1, okay, and see if this makes this equation. Okay, so let's plug it in. Okay, we're going to get 0 minus 1.5 squared plus 3.5. Okay, that equals 5.75. So that does not equal 1. Okay, what have we missed out here? Our first guess was a good guess, but not good enough because there might be a coefficient before those brackets. Okay, so we now know that our function must look like something like this. Okay, we know that there must be some number here before it. What we're going to do again now is plug in our y-intercept, 0, -1. This should be negative. Okay, 0, -1. Okay, and that will give us a value of a. So let's do that. -1 equals a times -1.5 squared plus 3.5. Okay, after working this, a equals 2. Okay, so all in all, okay, the equation of our graph is y equals 2x minus 1.5 squared plus 3.5. Okay, that will give us, -2. Okay, that's our final answer. Y equals -2, x minus 1.5 squared plus 3.5. What did I do? Again, I knew I had this vertex, so I wrote it out in vertex form. I then knew I had a y-intercept, plugged it in to check. Okay, got a mistake. Okay, that didn't give me the right answer, so I know that my vertex form must have some kind of coefficient before the square. Okay, I just wrote a, which is the number that I wanted to find out. I wrote a, and then again, I plugged in my 0, -1. Got a result, a equals -2, plugged that in. This is now what my equation looks like. Okay, that could definitely be a question in the exam. Okay, just to give you a graph like this, okay, and asks you to write out the formula. Okay, so you need to copy this down. Okay, good practice for these would be page 152, questions 43 to 48. I'd say try out either 47 or 48 first and see if you are correct. Okay, actually in your notebooks I'd like to see you doing at least one question. Okay? Okay, let's do a nice long wordy question from chapter 3.3 or 3.4. Okay, so An electronics company currently charges $15 for a certain item and wants to raise the price. The analysts found that the revenue of this product can be modeled by Rx equals minus 100, x minus 3, x minus 4, where x is the number of $2 increases in price. Okay, and it's asked me in A to tell them find the price that will maximize the revenue. What is this price? Okay, so the minute I see this word maximize, okay, I know that I'm going to have to find the vertex of this formula. Okay, shouldn't be too difficult. It's just completing the square like we just did. Okay, so I'm going to complete the square. So we know that Rx equals 100 x minus 3 x minus 4. Now I'm going to factor this out, but I'm going to be clever about it. I'm going to only factor these two. Okay, I'm going to keep this negative 100 at the beginning. Okay, I'm not going to multiply by it. So this equals negative 100 x squared minus 7x plus 12. Okay, again, looking at this 7, dividing it by 2, 3.5, and then squaring it. 3.5 squared is 12.25. So that's what I'm going to do. Okay. If it's not clear what I'm doing here, go back to the previous slides. Okay? I'm doing exactly the same process. Okay, so I now know that my vertex, let's do it in a different color. I now know that my vertex is 3.5, 25. Now, we're not finished here yet. Okay, it's asked us, we know that x, okay, is the number of $2 increases in price on top of that 15. Okay, now we know that the x that gives a maximum, because of the vertex, is 3.5. Okay, so we know that my final price will be 15 plus 3.5 times 2. Okay, 15 plus 7 is 22. That's my final price. Okay? Okay, now B. They've asked me, what is the revenue? Okay, that basically, they mean, what is the revenue at this maximum price? Okay, so all I need to do is plug in my x to here to get the y. Yeah, I know that my maximum revenue, the maximum of this graph, because it's a parabola that opens down, okay, the maximum it gets to is this 25. So the answer to this is 25. Okay, you need to be copying this down. Good practice for these would be page 153, questions 84 to 90. Okay, in your binders. Okay, in your binders I want you to do at least one question. Okay, I'd like to talk very quickly about the domain and range of a quadratic function. Okay, so we've seen this before. Domain is basically all the x's that can be in this function, okay, and the range are all the y's. Okay, so let's look at this function over here on the left. Okay, so for a quadratic function, the domain is the x's, okay, that satisfy this function. Okay, the x's that this function reaches. Now, these two lines, they continue until infinity. They go further and further along. Okay, I can plug any x I want into a quadratic formula. Okay, so my domain will always be all real numbers for a quadratic function. Yeah, remember that a quadratic function is something like ax squared plus bx plus c. Okay, now my range is not all real numbers. My range are all the values of y that this function takes on. Now I can see that if I'm up here, okay, this function does not cross these y's. Okay, this function only exists down here on my y-axis. So this is the function from before. The vertex was 1.5, 3.5. Okay, so to get the range, I'm always looking at the y. Okay, so for my range, I can see that y must be smaller and equal to 3.5. Okay, if I plug in any y that's bigger than 3.5, I'll get no solution. Okay, there will be no x's that I can plug in or that I can find that will give me y equals 4, for example, or y equals 5. Okay, I can see that from this. Okay, so if I might be given a graph. Okay, I might also be given an equation. Okay, I might be given an equation like this, just with some numbers. Okay, if I'm given a graph, I can just do it by looking at the graph. Okay, if I'm given an equation, what I will have to do is, again, complete the square, transfer it to standard form. Okay, then look at the vertex. Okay, think about if the parabola is opening up or down. If this parabola was to be opening up, yeah, it would be y bigger than. But this parabola is opening down, so its y is smaller than. Okay? Another thing to think about is the axis of symmetry. Okay, the axis of symmetry is a line, an imaginary line that I can draw on, at which the function is symmetric to. So here I've drawn it on. Okay, this line will always go right through the vertex. Okay, and it will always be parallel to the y-axis. Lines that are parallel to the y-axis always look like x equals. Okay, and in this case, x equals 1.5. Okay, because we can see that it passes through my vertex, and my vertex is 1.5, 3.5. Okay, that is my axis of symmetry. Okay, but again, if I'm not given a graph, what I will have to do is find vertex form, okay, and then graph it. Okay, so to practice this for your test, I'd like you to list the vertex, domain, range, and axis of symmetry for the following functions. Okay, so to list the vertex, range, axis of symmetry for these two. Okay, so each time what you need to do is, first step, transfer to vertex form. Then graph. Then find range. Range and domain from graph. Then find axis of symmetry. Okay? Okay, let's do a question from chapter 3.4. So, my good friend Sue has 4,000 meters of fencing and needs to enclose 3 sides of a field because one side borders on a highway. What are the dimensions of the field that maximize the area? So, let's do a little sketch. Here's our highway. Here's our rectangular field. Okay, let's call this one X. Let's call this one X. And let's call this one W for now. Okay? We know that X plus X plus W equals what? 4,000. Okay, so we know that 2x plus W equals 4,000, or in other words, W equals 4,000 minus 2x. Okay, copy this down with me. Okay, I want you to copy out this drawing as well. Okay, so now instead of W, we can write 4,000 minus 2x. Okay, and now they've asked us for the area. Okay, the area of a rectangle is one side times the other side. Okay, very simple. Okay, they've asked us what are the dimensions of the field that maximize this area, so we're going to have to factor this out. Okay, and then find the vertex, put it into vertex form just like we've done a million times before. So let's do that again. Okay, what I will end up with here is negative 2 x minus 1,000 squared minus 1 million okay, and that would leave me with the grand total of okay, so write this down while I'm doing it. Don't just sit there watching me do all the hard work. This needs to be in your binders. Okay, so I can see that my dimensions, my x will equal to 1,000 and my y will equal to 2 million. Okay, that's the vertex. Okay, so I just plug that in here. Okay, my dimensions are now. Okay, so we will get x equals 1,000. Okay, so the dimensions are 1,000 here. Here, it will be 2,000, yeah, because it's 4,000 minus 2x. So the dimensions are 1,000 by 2,000 by 1,000. Okay, and if they were then to ask you for what is the maximum area, it will be this, 2 million. Okay, so for practice, you can do page 160. questions 7 to 10. Okay, we're going to do chapter 3.5. We're just going to do one question from there. Okay, 3.5 is inequalities with quadratic equations. So something like this. So it's asking us to solve this inequality, okay, to give us values of x that will satisfy this. Okay, and we notice that this is a parabola. Okay, we can, first thing to do is to graph it. Now, we can graph this by completing the square, okay, but this parabola is basically x squared, which we already know, shifted down by 4 units, so the graph would look something like this. Okay, so this is the graph of x squared shifted down by 4 units, and it's asked us where is it smaller than 0, or where is it below the x-axis. Okay, so to do this we need to find, the first step is to always find the x-intercepts. Okay, and we do this by writing it in intercept form. Intercept form is x minus a times x minus b. Okay, and that's easy. That's just factoring it. Okay, so for this function, x squared minus 4, should be pretty easy to see that this is x plus 2, x minus 2. Okay, so my intercepts are, my x-intercepts are -2, 0, and 2, 0. Okay, so I can now see that my parabola itself is below the x-axis when x is between here and here. Okay, between the two x-intercepts. Okay, between -2 and 2. So my answer is x is between -2 and 2. Okay, that's my final answer. Notice that if it would have asked us smaller or equal to, then the answer would be smaller or equal to. Okay, but it hasn't. Okay, so for practice, you can do page 166, questions 7 to 22. Okay, every time it's just finding it in intercept form, okay, and then graphing it from the intercept and then looking, is it small below, does it need to be below the line, does it need to be above the line? Okay, that's about it from me. That is your review for the chapter test at the end of this week. I'd like you to have taken notes. You can obviously rewind this slide and take notes. I need to see those notes in your binders for the review. Okay. In the class before the chapter test, we will be doing lots of these questions, these practice questions. Okay. Thank you very much.